In this lesson, we will explore recursive formulas for sequences. In this video, we will use a slightly simplified version of the mathematical notation for recursive formulas for sequences. In a future video, we will cover the exact mathematical notation for recursive formulas. A recursive formula for a sequence has multiple parts. First, it defines the first term or terms in the sequence. Once the first term or terms are established, then the recursive formula will tell you how to find the nth term for one or more previous terms. So let's take a look at what this might mean. Let's say that we want to generate the first couple terms of a sequence. I'll make it 3 terms of a sequence. Now, in a recursive formula, we have to do 2 things. The first thing we have to do is tell what the first term or terms are. In this case, we're just going to get the first term. So generate the first 3 terms of a sequence, whose first term is 5, and whose nth term can be found by adding 3 to the previous term. So we want to find the first 3 terms of the sequence. Now, we weren't given a variable to represent the sequence, so we can pick whatever variable we'd like. I'm going to pick a. And if we're looking for the first 3 terms, that's a sub 1, a sub 2, and a sub 3. The first term is very easy to find in a recursively defined sequence. The way that we've defined this sequence, we were given that the first term is 5. So there's no question here. A sub 1, which represents the first term, must be 5. The second term is not given to us, so we have to use the idea for finding the nth term. The nth term, in this case the second term, can be found by adding 3 to the previous term. So all I have to do is take the term that came before a sub 2. Which term comes before a sub 2? A sub 1. The first term comes before the second term. So what I'm going to do is I'm going to take a sub 1 and simply add 3 to it. Substituting. A sub 1 is 5. So I'm going to substitute in to a sub 1. I know that that is 5. And then I'll add 3 to it. So a sub 2 is simply 5 plus 3, which is 8. I can do the exact same thing for a sub 3, which is the third term. All I have to do is take the previous term and think to yourself, which term comes before the third term? Well, that would be the second term. So I'm going to take the term before a sub 3, which is a sub 2, and add 3. Well, I know what a sub 2 is. A sub 2 is 8. So I'm going to substitute in 8 for a sub 2 and simply add 3. And 8 plus 3 is 11, so the third term is 11. So what I've done here is generated the first 3 terms of the sequence, just like we were asked. The first term is 5, the second term is 8, and the third term is 11. We can generate as many terms of this sequence as we would like. We were just asked to find the first 3. Now, if you've studied explicit formulas for sequences, hopefully you can find an advantage of explicit formulas over recursive formulas. If we wanted to find the 50th term, for instance, given just the information in this loosely defined recursive formula, we would have to find each term before the first term, the second term, the third term, in order to find the 50th term. because if I want to find the 50th term, I would first have to have the 49th term. Because in order to find the 50th term, I have to know what the previous term was, so I can add 3 to it. Well, if I need the 49th term, I need the 48th term to find it. And you can see that this process is going to have to keep going. I'll need the 47th term, the 46th term, all the way down until I get to that very first term. So if I want to find the 50th term, that means I have to generate all 50 of those terms. And that's one disadvantage of a recursive formula. Now let's take a look at a little bit more advanced notation here. This still isn't quite to the level that we're going to get to in the next video, but it's going to build up to that. Usually recursive formulas are given using a brace like this to show that the two rules that we're going to give go together. And we're going to be given the first term, which is usually given by a sub 1, or some variable, whatever the variable is that we're using for the sequence. It might be t sub 1 or any other variable. If we're given that the first term of a sequence is 2, we then need to know how to generate the nth term. The nth term, in this case, can be found by taking 4 and multiplying it by the previous term. This notation gets a little bit closer to the formal mathematical notation of recursive formulas. In the last example, we just had words to give us our formula. Here we have slightly more mathematical notations, and if we're again told to generate the first 3 terms, that would mean that we're looking for a sub 1, a sub 2, and a sub 3. You might be asked to generate the first 5 terms or the first 7 terms. You can do the exact same process to go as far as you need to. A sub 1 is always the easiest term to find because it's given to you. A sub 1 is 2. To find a sub 2, I need to take 4 times the previous term. Well, the term that comes before a sub 2 is a sub 1, so this is 4 times a sub 1. And a sub 1 is 2. So I'm going to substitute in for a sub 1. I know that it is 2. Therefore, the second term is simply 4 times 2, which is 8. The third term, again we're going to use this formula. The nth term, and in this case I'm looking for the third term, is simply 4 times the previous term. So it's going to be 4 times the term that comes before the third term is the second term. 4 times the previous term. So a sub 3 equals 4 times whatever a sub 2 is. Well, a sub 2 is already found, it's 8. So the third term is 4 times 8, which is 32. So here, if we were asked to find the first 3 terms of this sequence, we have done that. It's 2, 8, and 32. Like I said, in the next video we'll talk about the exact mathematical notation for finding or for noting recursive formulas.